Yes, greetings. In last session we discussed some problems related to transmission, right? And today we'll get started with introduction to brake system. Okay, we'll go through the brake components and hydraulic uh, components of the brake system today, and then in next section we can have discussion on anti-lock brake system and braking analysis. Okay, so let's get started with this. I will be using these notes today for uh, for our discussion. All right. So we'll go through these notes while having a discussion so that we can effectively get started with the braking components, and then we will discuss other things such as ABS and all in the later session. So, okay. Yes. So let's get started. So, what are the brakes? Brakes are devices which help us stop the vehicle which is in the motion, and we'll focus today on friction braking, where the kinetic energy of the vehicle is dissipated into uh, atmosphere as thermal energy, right? So, if you were to consider a vehicle with mass of 1000 kilograms and we were to go from 0 kilometers per hour, that is standstill, to 72 kilometers per hour in 20 seconds, the average acceleration would be 1 meter per second square, and acceleration power would be change in momentum over time, right, as 100 kilowatts. So if we were to achieve this acceleration, we want a 100 kilowatt power train. But if we were to break this in 4 seconds, we would need to dissipate 500 kilowatt. So you can see that the uh, demand of power dissipation in braking is significantly higher than that of acceleration. So the function of a brake is to decelerate the vehicle and stop it when it is necessary, and that means we should provide sufficient braking force, right? And if we are going downhill, then we would like to dissipate energy in a controlled manner so that we can regulate the speed of the vehicle. So whatever the component of gravity which is coming while going downhill, that should essentially be dissipated. So the force component of W sine theta needs to be dissipated. And finally, we would like to hold the vehicle on a stationary grade. So if we are climbing up and we are required to stop, in such a case, the brakes would be important. So let's quickly go through how the braking system has evolved over time. So the initial idea which we also do have in our bicycles is that we have the rotating rim and we press against it, right? A stationary element which would then result in friction and energy dissipation. So initially wheels were braked by wedging a shoe against their rim. So as we used to do in bicycle. Later on, uh, then came the external contracting brake. It's like a band brake where a strip of metal with brake lining is held outside the rotating wheel hub or the drum, and a brake lever is used to press against it. So when the brake lever is pushed here through some effort, the resulting motion pulls the brake band, and that results in contracting this ring. So the brake lining rubs against the drum, resulting into uh, the generation of braking force. Then we had internally expanding drum brake. right? Internally expanding brakes, like the drum brake shown here, where we can see that there is brake lining on the brake pad, which is sitting inside the drum, and we generate motion uh, as shown by these arrows, so that the brake lining rubs against the drum for causing the braking action. Okay, then we moved on to disc brakes. So let us have different grouping of the brakes. So the brakes which we used in normal condition are called service brakes. Those are your primary brakes. Then you have secondary or emergency brake, which can be used during partial failure. And finally, you have parking brakes. You engage the parking brakes in a condition where yeah, today we will be discussing introduction to brake system, so that we have prerequisites for anti-lock brake system, and if time be, we can have some more discussion. We can get started with ABS, so we'll see how it goes. Okay, so let's take a look at various kind of distances we are defining. Right, the stopping distance is the sum of distances covered in three different times. First is the driver reaction time, then there is brake reaction time, and there is braking time. So when the braking is required, the driver would take some time for reaction. So that is called the driver reaction time. Post which the brake system would also take some time to respond. For example, in air brake systems, the air has to travel from the reservoir, which is used in heavy vehicles like trucks and buses. The air has to travel from the reservoir to the brake chamber, right? So that transport of air from point A to point B during braking takes some time. Similarly, even the hydraulic system would take some reaction time. Okay, since it will take some reaction time, this reaction time is called brake response time. And finally, there is braking time, that is the time during which the vehicle is actually decelerating. Right, your deceleration would also depend on the tire road interface and how fast or how slow can you or how fast can you decelerate. So uh, your stopping distance would include the distances traveled between this response time or reaction time, as well as the time you spend during the braking. Second thing we should note is that of braking stability, that is stability of the vehicle during braking. A good brake must ensure that a short stopping distance is met while maintaining the vehicle in stable condition. Okay, this requires proper distribution of forces in the front and rear wheels. So what do we mean by stable braking? Is that your wheels should not lock. In case your front wheels lock, it results in loss of steerability. Right. So that means if your braking force results into a brake is higher than what your tire rod interface can sustain, then you are going to go towards wheel lock condition. For example, if we were to consider a road surface which has low friction coefficient, because say it has rained on the road and the road is wet, so the friction tire at the tire rod interface will not be sufficient, uh, or will not be as high as what it would have been on the dry road. So if you were to apply brakes which results in a braking force that cannot be sustained by that tire rod interface, we are going to see the wheel lock. And if your front wheels lock, that would end up being loss of steerability, and your rear wheel lock may result in some kind of undesired yaw motion. That is, your vehicle may spin out of lane, and in such a case, the braking is deemed as unstable braking. So, to ensure stable braking for the design condition, it is required that proper distribution of brake force at front and rear wheels is maintained. In a case where the proper braking force cannot be, in a case which is not your design case, for example, in trucks and buses and all the vehicles, your brakes should be designed in a way that the maximum load your vehicle is expected to carry, uh, we should be able to stop it safely. So, in some cases where the braking forces are way too high, that means if your vehicle is empty or your tire road interface does not have sufficient uh, capacity to provide braking forces in a stable manner, we are going to have overpowered brakes, which actually results into which can potentially result into wheel locks. So, in such scenarios, we will be using anti-lock brake systems. Then, the third point we should note is that of reliability. The transmission, right, which includes mechanical linkages, hydraulic systems, or compressed air systems, is typically the weakest link in the brake system. Hence, redundancy is introduced that has led to use of dual circuit brake systems. So, what are dual circuit brake systems? These are the systems where you have two pathways to provide power to the brake system. Okay, so that if in case there is a leakage in the system, you still have some capacity to brake rather than losing it entirely. So let us go through various components of a brake system. Okay, so we'll be looking at sources of energy. First is the human effort, right? In the bicycles and bikes, we use uh, the energy completely provided by us in order to generate the braking force. However, that may not be sufficient in case of passenger cars, the newer ones, and even commercial vehicles. So we have systems like vacuum booster, which essentially uh, takes human effort as a signal and amplifies that signal so that sufficient power can be externally taken in. Then there is power brake, where the driver input is used to modulate a source of energy, that is air brakes. So what we do in air brakes is that we have a small pilot signal which is sent by the driver, and it opens another valves in order to provide full power to the brake system. Okay, then we have mechanism of applying brake. So we have a foot pedal or a hand lever, which is used in case of emergency brake. So a vehicle should have at least two ways of applying brakes if in case one has an issue. Third is the energy transmitting medium. So here we have various entities. First is the mechanical brakes, where we have use of levers, rods, cables, etc. to transmit energy from the human interface, be it pedal or lever, to the final brake pads. And then we have hydraulic brake, where incompressible brake fluid is used. We have air brake systems, which are used in heavy commercial vehicles, which uses compressed air. So this compressed air can be filled in again and again. The benefit of using compressed air for heavy vehicles is that it first allows you to power, uh, it allows you to operate at pressures which will enable the kind of power which is required for stopping the commercial vehicles. And you might have seen tractor trailer arrangements where one tractor is connected, one uh, vehicle has a trailer connected to it, or multiple such trailers connected. So when we want to connect a tractor and a trailer, we can easily connect air brake systems, and there is no risk of leaking of brake fluid because air is the braking fluid. Uh, right. So it provides a clean interface, and if in case there is a leakage in the system during the transmission, we can continue running the compressor of the air brake system, which will keep refilling the compressed air at a reduced capacity of at the reduced capacity of pressure, but this would still be a usable system, right? And we can have combination of all of these above. Okay, so in energy transmission, which happens to be which is typically a weaker link, we have split systems like single circuit systems and dual circuit system. So, single circuit system, we only use circuit for transmitting the energy required for braking, and there will not be any braking available if in case this circuit fails. On the other hand, in the dual circuit systems, we use two circuits to transmit the energy. Partial braking is available in the event of failure of one of these two circuits. Then coming to the foundation brakes, these are the primary brakes which we use for dissipating the energy as friction. So these are brakes at wheels, and they are typically categorized into drum brakes and disc brakes. Uh, so let's take look at each one of these now, starting with drum brakes. Okay, so in the drum brakes, it has multiple components. So here we are looking at drum brake system of a truck from which the brake drum has been removed so that the internal components are visible. So here you can see the friction, brake friction lining. This is the material which actually rubs against the drum to generate the braking force. This brake lining is mounted on a brake shoe. Okay, this brake shoe has uh, these roller pins, and it is mounted with these pivots. Okay, so mounting of this brake shoes have following entity, following things. There is one spring here and another spring here. These are the springs which keeps the brake shoe at its position so that it does not randomly go and rub against the drum. Okay. Then there is this cam called as S cam. If you rotate this S cam, it generates the force which pushes at these two pins. Okay. And this S cam is rotated using series of arrangement. First you have a slack adjuster, and then you have a brake chamber. Okay, so these two, this rotation of S cam generates the force for more needed for moving these. Okay, so these this S cam generates the motion and presses these against the drum. So if you were to look at a hydraulic counterpart, we can see that there is this wheel cylinder where the hydraulic fluid comes in, which results in the motion in this direction instead of S cam. So here this ends up pushing the this ends up pushing these brake shoes onto the drum. Okay. So based on this motion, there is a notion of a trailing shoe and a leading shoe, which is defined with respect to relative motion of the wheel. So for example, if this is the direction of rotation, this shoe would be the leading shoe, which rubs against it, which rubs against the drum, and the other one would be the trailing shoe. Okay, so there are two kind of issues which can happen with the uh, these drum brake systems. Okay, first is thermal expansion of the brake drum. It results in increased clearance, right? And then there is brake fade. That is reduction in brake friction lining coefficient with increase in temperature. So now let us quickly go through some analysis. Okay, we are neglecting the weight of the brake shoe and we are neglecting the spring restoring force. We'll take the moment about pivot point, assuming that the inertial term is negligible. Okay, we are saying that mu is the brake lining friction coefficient. So, and Fa is the actuation force. Okay, and your contact point is say A distance away from here, and it is B distance here, right? With the height considering as h. So if we write the moment balance, we get that Fa into h plus mu into NL, that is the normal loading force, minus NL into B. So the torque due to friction augments that due to that of the actuation force. Right, this is termed as self-energization. So friction from the leading shoe is mu into NL, and the brake factor of the leading shoe is defined as mu into NL over Fa, that is mu into H over B minus mu into A. So this is function only of the geometry as well as the friction lining coefficient. On the other hand, if we were to take the moment about the pivot point for the trailing shoe, we can see that it is mu into Fa into H divided by B plus mu into A. And the brake factor for trailing shoe is this. So if we were to write the brake factor for drum brake, it will be summation of brake factor for a leading shoe and the trailing shoe. So this is mu into H over B minus mu A plus mu into H over B plus mu A. So the brake factor, the same way can be calculated as it will be least for the leading trailing shoe, leading trailing type, which will be better than duo servo. And if we have both of them as leading, then it will be the highest. Okay. Now coming to the disc brakes. Here in the disc brakes, we have the rotor and the brake pad. Okay, brake pads are put into the caliper assembly, and the idea here is that if we put a pressurized fluid on one side, this brake pad would make contact with the rotor, and once the brake pad makes contact with the rotor, uh, will start generating the braking force. So there are two kind of disc brakes: fixed caliper type disc brake and floating caliper type disc brake. Here we are showing at a floating caliper type where we are putting pressurized brake fluid in the one side, and since the caliper is floating, uh, the brake pads clamp from the from both the sides onto the rotor. At steady state, where n equals to F into A, friction from the brake pad is mu into N, that is mu into Fa. So brake factor of one brake pad is mu. So brake factor of the disc brake is 2 into mu. So if we consider same value of friction coefficient, considering that the brake pad as well as the material of disc or the drum is exactly same, we can say that brake factor of a drum brake is higher than that of a disc brake. That means the drum brake will generate more brake force output from the drum brake of the same actuation force. And from obtaining the same brake force, a smaller actuation force is required in a drum brake. Okay, that would essentially mean that uh, we should be working on with drum brakes rather than disc brakes. But then why do we use disc brake is because of mu sensitivity. Okay, this mu sensitivity is indicative of the change in brakes performance with the change in mu. So if we were to take a look at the brake factor versus the value of mu, okay, a small change in mu, say delta mu, would result in a large change in the drum factor, that is brake factor, that is delta bf for drum brakes when compared to that of disc brakes. This means that the disc brakes have a lower sensitivity mu sensitivity than drum brakes, right, which would imply that it is more reliable. This implies that we'll get more reliable brake force output. On the other hand, disc brake also have better heat dissipation characteristics. You might have seen the disc brakes with holes in it, which help with better dissipation of heat. So, in most passenger cars, you may observe that disc brakes are used in the front and rear, and the rear wheels would have drum brakes. This is because typically more normal load is available on the front wheels, and there is more potential braking force from the front, and we need a reliable brake on the front side. This results in choosing of disc brake on the front, which is more reliable, which is more durable. Now let us take a look at various components of hydraulic brake system. Okay, in a hydraulic brake system, an incompressible brake fluid is used as the energy transmitting medium. It has following components. First, you have a foot pedal where the driver's input is given, right? It is mechanism for the driver to apply brakes. When the driver applies brake, the first that force which is applied by the driver, or the effort which is applied by the driver, is mechanically amplified with the lever and is given in the vacuum booster. The vacuum booster helps amplify yes, so the vacuum booster amplifies the driver's input and results in the motion in master cylinder. So there are two lines in the master cylinder. Okay, it's dual circuit, that has primary and secondary. So the vacuum booster augments the driver's brake input force and the master cylinder takes in mechanical force and converts it into the fluid pressure proportionally. Alright, so the mechanical force is converted to a fluid pressure. So this master cylinder has two circuits, primary circuit and secondary circuit. It can have a diagonal split or X split. For example, if we were to take this here and trace this line, the pressure comes here and it gets here and here, which is diagonally opposite wheels, and the secondary circuit goes to the two other wheels. That means in case of failure of one of the transmitting lines, we will still have pressure on. So we'll have the primary circuit and secondary circuit. So even if one of it fails, the other one should be able to function. Yes, just 1 second. Okay, so that this kind of dual circuit provides some level of redundancy and improves the reliability of the system. So let's take a look at what the vacuum booster does. Okay, so there is partial vacuum on one side, and on the other side there is high atmospheric pressure, and there is a diaphragm in between. Yes, so yeah, today we are discussing the brake component, and we just got started on hydraulic brake system. So to summarize quickly, the hydraulic brake system has a foot pedal followed by a vacuum booster and a master cylinder. The driver's effort is given through this foot pedal, which goes to the vacuum booster. The function of vacuum booster is to augment the driver's brake input force, and this results in motion of the master cylinder, which converts the mechanical force to fluid force. We have two different lines, primary line and secondary line, which is pressurized in the master cylinder. Okay, so the primary line goes to two wheels which are diagonally opposite, and the secondary line also goes to two wheels uh, which are the other two wheels, which is again a diagonal. So in case of one of the circuit failures, we will still be able to have sufficient robustness to stop the vehicle and not completely lose out on the not completely lose out on this braking functionality. Okay, so let's take a look at the vacuum booster. So the idea of this vacuum booster is to uh, increase the mechanical force which is given by the driver. So what we do is, uh, on the either side of diaphragm, we have air at partial vacuum, that is low pressure when compared to the atmospheric pressure. And once the foot pedal is pressed by the driver, this motion results in uh, opening of some valves. Opening results in opening, which allows the air at atmospheric pressure, which is at higher pressure than inside, to flow in. When as this air flows inside, it pushes the diaphragm, resulting into the boosting of the force which was given by the driver. Okay, so this uh, motion goes to the master cylinder. If we consider this force FVB coming from the vacuum booster onto a push rod, so this is the master cylinder. This converts the force output from the vacuum booster to a fluid pressure. So there are two pistons, primary piston and the secondary pistons, which is separated by springs. Uh, and there is a reservoir which contains oil. So as we press in normal condition, the valves are closed and the fluid will not be flowing in. But when we press this, the pressurized fluid will flow through. Okay. So even if there is failure in my secondary circuit, my primary circuit will be pressurized and I will have some uh, braking capability available. Okay, so then the next component is the wheel cylinder. A wheel cylinder is something which takes in the oil coming from the master cylinder and results in outward motion of two pistons. Okay, so these two pistons generate force and pushes the brake drum. When these brake drums are being pushed against pushes the brake shoe. Okay, the wheel cylinder converts the fluid pressure to an actuation force on the brake shoes of a drum brake. This results in the generation of braking force. Now we may have combination valves which are found in most cars with front disc and rear brakes uh, to achieve the same functionality. So let's take a look at proportionating valve, which ensures that the fluid pressure provided to front and rear brakes are proportional or distributed appropriately. So we want more brake force output on the front brake, and disc brakes also require more actuation force to generate a desired force. So why do we need more brake force output on the front wheel? Is because of dynamic load transfer. As you would have traveled and applied brakes, you would result in a forward motion because of your inertia. That same thing carries on to your vehicle as well, and hence there is dynamic load transfer from the rear wheels to the front wheels, equations of which we will discuss in next session, I think. Okay, so because this dynamic load transfer happens, the normal load on the front wheels is higher than that of the rear wheels. That means more braking force can be generated at the front wheels, and hence we would require more brake force output from the front brakes. Second is we have pressure differential switch, which is used to alert the driver if there is loss of pressure in either circuit. And then we have metering valve, right? So the drum brakes take slightly longer to be applied than disc brakes, and this valve delays providing brake pressure to front disc brakes, therefore providing sufficient time to apply the rear drum brakes. Okay, And as we are looking at hydraulic brakes, let's take a look at uh, some brake fluid. Okay, so desired properties of brake fluid are as follows. You should have higher boiling point, it should have low compressibility, it should not corrode the metal parts, it should have good lubricating properties, and should have low toxicity. So common brake fluids are glycol based fluids and silicone based fluids. Okay, so each one of them have their own benefits. Then we can briefly look at brake linings. So brake linings are the things which we will replace as they wear out. Okay, it's a replaceable component, and this is the one which generates the braking force. So the quality of brake lining uh, is the quality of brake lining affects the friction coefficient between the brake lining and the drum, or say brake pad or the disc, and can have different can result in varied braking performance. So it has fibers, fillers, binders, and friction modifiers. Okay, so the job of fibers is to provide rigidity and add strength to the lining. Uh, we used to have asbestos, but the standards today explicitly specify that we should not have asbestos in the fibers. We have one with mates with steel wool, and we have fillers. These are uh, the ones that extend the lining life and fill space to minimize the cost. So you can have clay, calcium carbonate, or some metal powders as fillers. Then you have binders which hold everything together. And finally, you have friction modifiers that aid in better friction characteristics. So that is all about the pneumatic system. Now let's take a look at air brake system. Okay, the air brake system, compressed air is used as the energy for transmitting the media transmitting the energy. Okay, these are used in heavy commercial road vehicles or HCRVs like trucks, buses, and tractor trailers. So here, the driver's input results in metering out of compressed air from the storage reservoir to the foundation brakes. Here also we have primary and secondary circuit. So primary circuit going towards rear and secondary towards front. So let's this has various components. So let's take a look at each one of them. Okay. So the driver's input is given to the treadle valve or the brake valve, which mechanically takes in the signal and proportionally connects the reservoirs to the brake chambers. Okay. This pedal is also connected to the stop light switch, which enables the rear braking lights. Along with that, it also enables along with it, it can be given to the electronic control unit for anti-lock brake system. Then we have various valves like quick release valve, parking brake control valve, uh, and service relay valves. We'll come to each one of them one by one. So idea here is to run a air compressor which keeps on filling these reservoirs uh, at a pressure of around 10 bars. And the brake system operates at 8 bar of pressure. Okay, so let's take function of each of the valves. First one is the quick release valve. This quick release valve enables the quick release or exhaust of the air from the front brake chambers once the brake is released. Okay, so when the driver uh, removes his or her feet from the brake pedal, the air inside this is quickly released. Air inside the brake chamber is quickly released. Okay, so the brake chamber is the interface which takes in compressed air and results in linear motion. Uh, this linear motion is then used by a slack adjuster to rotate the S cam, which results in actuation of foundation brakes. Okay, so let's take a look at various components of the Friedel valve. So first is the pedal input, which results in this motion. It moves the primary piston and the relay piston. Okay, so there are two reservoirs, one for front and one for rear, which are connected uh, on the input side, and there is the delivery side, which allows for airflow from which allows for proportional airflow depending upon how much the brake pedal is displaced by the driver. Next is relay valves. So since a heavy commercial vehicle has longer lengths, uh, valves like relay valves are used so that uh, the brakes can be applied faster. Okay, helps in faster application and release of the rear brakes, because the driver is sitting all the way in the front and we need to provide that signal as early as possible to the rear wheels. Then, yeah, so here in the treadle valve, let us denote the supply ports as S, exhaust port as E, and delivery port as D. So when the brake is not applied, the delivery port is connected to exhaust port, automatically resulting in release of the air from the uh, circuit. And when the brakes are applied, we are closing the exhaust port and connecting the supply port to the delivery port. Okay. Further motion of primary piston opens the primary control valve and the air flows from supply to delivery port. Now let's take look at the relay valve. Okay, so this is the control port that receives compressed air from the primary circuit of the treadle valve, and it opens up it essentially relays the information from the driver, so that the compressed air can flow uh, to the rear brake chambers at a faster rate. So once the compressed air reaches the brake chamber, the diaphragm moves in this direction, resulting in motion of the push rod. The linear motion of the push rod results in angular motion of the slack adjuster, which moves this S cam. So the motion of S cam generates the force here at these two roller pins, causing the brake lining to rub against the drum, and this results in braking. Okay, so This is the shape of this cam is like the letter S, and hence it is called S cam. Okay, the brake chamber area and slack adjuster arm length would dictate this. We can change the size of brake chamber for having different levels of braking forces. Now let's take a look at a slack adjuster. The idea here is uh, that as your brake lining keeps wearing out, uh, some minor adjustments needs to be made so that your brakes are functional. Okay, that is why we use this slack adjuster. So if we were to characterize the push rod stroke against the brake chamber force output, this is how the curve looks. You can see that at very low push rod stroke, we get some force output. It is by and large stable up to a limit, and then it rapidly starts decreasing. So this limit is called the readjustment limit, where we are expected to adjust the slack adjuster so that we operate in this region. Okay, so the tactile feedback is available to the driver uh, is lower in an air brake system in presence of a leak, of course, right? Because if things start leaking, then driver will feel it easier to press and will not be able to uh, gauge from the feel of the pedal. So slack adjusters are of two types, manual and automatic. Okay, so there are self-adjusting slack adjusters, which as the brakes are applied repeatedly, it readjusts uh, minutely so that this readjustment limit is not reached. Now let's take a look at the parking brakes. So parking brakes are purely mechanical, right, and are done using cables. So you would have seen the hand lever, which you can use to engage parking brakes. That hand lever is connected by cables to brake shoes, and this motion of the parking brake cable results in engagement of the parking brakes. Okay, so let's take a look at the parking brake system in a pneumatic system. Okay, so we have a spring here. Okay, which so when we start the vehicle, the compressed air from the hand control valve flows inside this, and this compressed air holds back the spring. Okay, so if in case there is loss of pressure, either due to leakage or there is the signal coming from the hand control valve, this compressed air gets removed and these springs come into action, which results in uh, motion of the diaphragm, resulting in motion of push rod. So in case of brake failure, okay, so this is how we have in normal brake operation. The spring is held back, and this is how it is in case of the engagement of parking brake. It also acts as an emergency brake in the sense that if the compressed air is not going in the parking brake, the springs would engage, it would expand and engage the brakes so that the vehicle cannot move too much. So Uh, till this point, we wanted to have a discussion today, so that we can take up discussion on anti-lock brake system in much more detailed manner than what it is here. So we run a lab session on anti-lock brake system. Maybe we can bring some of those elements for the next session's discussion. And I would be open to questions now. I'm open to questions now for if you have any questions on the brake system or any other thing. Are there any questions? Okay. So if there are no questions, let's just close the session. We'll meet next time in next week where we'll have discussion on anti-lock brake system, and next to next week we will have problem solving sessions on the brakes aspect. We'll solve some problems on braking, and perhaps we can design a simple braking system on MATLAB Simulink. Okay, so thank you for joining. I'll see you next time.